This is our video presentation for a selected group project. The members of this team are James, Emma, Nora, and Liam, and your speaker for this presentation, Cassidy Lee. For our project, we have chosen to use real data from one of our team members' employers. Here's what we know. Sidel is a global company headquartered in France, operating in 190 countries. They supply machine parts to manufacturers of plastic packaging. HQ in France dictates stocking levels to their distribution facilities. The stocking amount for each part is dependent on their categorization system, wherein parts with the highest turnover rate are in category A, the next highest are in category B, and then C, etc. Our team member Nora is a procurement and project manager for Sidel's distribution center in Georgia. She told us a major struggle at the Georgia facility is that the number of parts France says they need to keep in stock does not match customer demand. This means that there are parts in their warehouses rusting and becoming unusable before they are ordered. Georgia has no input to how many of each part they have in stock, so this is a persistent problem. Initially, we started out with only 3 separate reports, each with its own data set. However, we did realize that we needed more data, and Nora was able to pull another report that contains the delivery information. This additional data set will be used to estimate the delivery time. Here's a snapshot of what that data looks like. For our project, we have been using multiple data sets with around 60 variables total. We were able to remove columns that were either unimportant, null, or constant. We were also able to remove a small number of rows rather than using imputation to fill in those missing values. So far, we've been able to narrow down the dataset to about 25 usable variables, and we plan to continue narrowing this down using different feature selection techniques to find the best feature set for our model. We may use highly correlated features or statistical significance as a feature selection technique. Out of the 1,983 unique items, we can see that they are not evenly spread between the 3 categories, with A having the least and C having the most. We can also see the average level of safety stock for each category, with A having the highest, and this could potentially be correlated with the high turnover rate for A parts. So we keep more stock for A parts, but we have a smaller number of A parts. So this helps us investigate the parts categorization, possibly identifying where there may be excess stock. Here we can also see the average number of purchase orders over time from 2019 all the way through 2022. This is the daily average per month, and it shows a slight upward trend as well as maybe some seasonality. And we can also see that around the summer of 2020, there is a slight leveling off here, where this may indicate some impact from COVID-19. While analyzing the data, we have come up with 3 potential methods to help us with our problem. We can use k-means clustering to determine if France's categorization of each part is correct. We can also use linear regression to estimate the number of days an order takes to ship. Then we can also still use linear regression to estimate demand for each item. And lastly, we can use logistic regression to estimate the probability an order will ship on time. We do recognize that there can be other models that can be used to do this, but we wanted to keep it to just models that we've discussed in class. Lastly, we have encountered a few issues. However, all of them we were able to overcome. Our team has faced some challenges largely because we chose to work on a problem with original data. Nora has had difficulty pulling exactly the data that we need without the system crashing because of the size of their database and the number of parts that they stock. Nora has also had to serve as our living data dictionary because she's the one that is familiar with the data and knows the meaning of the column names, because no other data dictionary is actually available. So because of the large file size, this made it timely to actually procure the data. There's also been some messy and unclean parts of this data. However, we were able to either fix those issues or remove a small number of rows. And here are some sources that we used for our project. Thank you.